All right. Hello there. So, we are going to apply some of the work that we've been learning about, um, both in the Making the Most of Story Problems article and in the two articles that we just read. So, it's important that we understand as we're looking at student work, it's complex. It's basically the art of teaching, right? We want to notice what the student does and says and interpret what they understand and then ask an intentional question that either clarifies, elicits, supports, or extends their thinking. So, as you saw in the article, that there are some questioning categories for supporting and extending children's thinking, and I've color coded them here for you and given you some arrows so you have some examples. We have eliciting questions, clarifying questions, supporting questions, and extending. So, basically, if you think about eliciting, you want the kid to start talking about their thinking. Clarify, you're unsure what something about something they did, and you want some clarification. Support, perhaps they miscounted, or perhaps you can help them look towards recording more efficiently or thinking about the problem another way. And extending, again, adding an additional layer of understanding to their thinking, perhaps enlarging the number set or maybe writing an equation. So we're going to now apply this questioning to a piece of work. The first one we're going to do together. I'm going to leave this slide here in the PDF for you, and we're going to jump right over to the Jamboard because I only have 5 minutes on this video, so I have to go very quickly. All right, so this is the problem that you solved. Here is sample L. This is direct modeling by ones. The young person did 36 children on the playground and 20 more came to play. How many children are on the playground now? And you've all seen this work because you all tried to identify it. Now, if we take a moment to just look at it and think, what do I notice the young person did, right? I notice here that they did some drawing of people, and here they made some marks. So the more precisely and the more specifically you notice, the easier it is going to be to ask questions. I noticed that they labeled 36 kids and 20 kids, and then they made these little marks here. So now I have some questions. So on the next slide, I showed you how I might ask some questions. And so this specific document over here is in Canvas for you, and it'll make more sense if you take a look at it now. But what I've done is I tried to create some eliciting, clarifying, supporting, and extending questions as an example for you here. So here we're going to elicit. Please tell me what decisions you made as you solved the problem, right? So it's kind of a question, but it's phrased as a statement. Clarify, please explain the dots in the circles near the 20. So right here, as we were noticing, we saw these little dots or lines. We want to know more about that. We know this is not a majorly efficient way of solving the problem, especially if we start increasing the magnitude of the quantities. So might there be another way to show the children? Maybe this young person could do a counting strategy. Maybe they can start to unitize a 10 and use tens to model instead. And then an extension might be, how might you write an equation to match your thinking? But sometimes it's hard to differentiate between extending and supporting. Supporting most often happens if there's an error in thinking, right? So perhaps they miscount and you ask them to recount or make sure that they have the correct quantity in the problem. And not every piece of work is going to have every type of question, but for the purposes of this upcoming exercise, we are going to try to ask each question of every piece of work. All right. So that is this video. And in the next video, it's going to be your turn.